In this video, I'm going to look at a sort of bizarre little bash program I wrote that's going to generate 8 versions of Hello World, but assign them different permissions and then try to do things to those files and see what doesn't work, what does and doesn't work based on those permissions. So here's the file. I called it hw hello world underscore maker.sh. And it is, here I am in documents test. And that right now is the only file. Let me do an ls sale. So there's dot, double dot, the directories, this current directory, its parent, and then this script. Okay. And then let's talk about the script, then run it, and then see what happens. Okay. So I have a for loop that is going from 0 to 7. So it goes over 8 things, 0 to 7. I am making a variable. I'm assigning a variable that is hello underscore and that number and then .sh. So that's just a variable that I'm concatenating. Hello underscore 0.sh, hello underscore 1.sh up to hello underscore 7.sh. I am using the touch command. So when you have touch and you give it a file name, and that file name does not exist in the folder that you are currently in, then it's going to create that file. So I'm creating files hello underscore 0 to hello underscore 7. Then I am in line 7. I'm echoing sort of a shebang / bin bash. So like just the first line of a bash program, and I am sending that over and appending it to the file name, $ file name. And then I'm making another line where I am echoing out. So I have the echo, the -e. So I'm recognizing escape sequences, and I'm writing the line echo quote hello world end quote, and I'm appending that to the file name. And then in line 9, I'm using the change mode command. I'm changing the permission of the file, and I'm changing it to $i, $i. So I'm going to give it permission 000, 111, 222, 333. So I'm going to give all the different permissions. I'm going to give the same permission for the user, the group, and the world. But I'm going to go through all the possible permissions of no permissions to all permissions, from 0, nothing, no read, no write, no execute, to read, write, and execute, all full permission. So I'm sort of making every pot. All the files are the same, but they're all the different permissions are being put onto those files. So each one will have a different permission. Otherwise, it's the same file. Okay, so now I am then in 12, just a separator, and then in 13, I'm just doing ls sale. So I should see, 14, I'm doing ls sale. 13, I'm just announcing that I'm doing ls sale. In 14, I'm doing ls -sale. So I'm just going to see that I've created these files. And because it's sale, because of the long listing, the L in there, we will see the permissions, and we will see that each one has a different permission. Okay. In 18, I start a new loop, and I'm creating the file name again, and I am trying to use cat to read and spit out the contents of the file. And a bunch of them are going to fail. Some of them are going to work, and some of them are going to fail. And the ones that fail, it's because what you do when you cat is you read the file and then display its contents. So those that we can't read are going to fail for the cat. Starting in 26, I have another for loop, and I'm creating the file name again. And then I'm trying to echo out a line that starts with a hashtag with a £. So it's a comment. So I'm sort of adding a comment to my little tiny script and writing and appending that to the file. And so we're writing something. We're writing a comment to the end of the file. And again, so we have different permissions. And when we don't have write permission, that should fail. Okay, what else? What other craziness is going on here? Starting in 34, we have a loop and we create the file name. And then we're going to run the command bash and then the file name. So we have the command bash and then the file. And these were all little bash programs that said hello world. Some of them have an extra comment in them. But that doesn't do anything in terms of the execution. And so we'll see which ones run and which ones don't. So to run in bash, we just need to be able to read them. You don't need to be able to, it doesn't require execution because of the word bash. So the bash is sort of runs the command and then, but we do need to be able to read the file. So this should be rather like the cat loop in that when we can't read, because it's not like binary code. It is code that's written out in text. And so it needs to be read to be interpreted. And so if we can't read it, it's not going to run. The last loop, starting in 42, we are, instead of using the command bash to execute the code, we're just going to do like a ./ and then the file name. And then we will need to be able to execute and read. Again, it's the code is not binary code. It is needs its words and need to be interpreted. So we need to be able to read the file. And then to execute the bash script without using the word bash, we need it to be executable. And so that last loop is only going to work twice when we have both read and execute. All right, let's run it, see if it does what we think it's going to do, and explain it one more time. Okay, so I don't have any fancy permissions. I don't have execute permission on the HW_maker. I can tell I don't have, it's not green, so it's not executable. So I'm going to run it with the keyword bash in front. So I'm running HW_maker.sh. And it's not, I should be .sh, not 2 underscores. Not paying attention. There we go. All right, so here we go. So let's do the side by side. So this first for loop makes a bunch of files and assigns them permissions. You don't see anything there, but it's working. Then we see ls-sale, and that is here. And so we see all the different hello. We see the dot, the double dot way at the bottom, the HW_maker. And then we see the 8 hello starting with 0 going up to 7. And we see that they all have a different sort of permission string, if you will. So the first one is all dashes. It's not read nor write nor execute. And then 1 executes and 2 writes and 3 writes and executes and 4 reads and 5 reads and executes and 6 reads and writes and 7 read, writes, and executes. Okay, so that's the sale. Now we are down to the cat loop. And remember that cat is going to read the file and spit out its contents. And so 0, 1, 2, and 3. Oh, I want to show this little thing. 0. So here are the numbers sort of written out as, so here are the numbers, here's the binary for those numbers, and that corresponds to read, write, and execute. So 0, 1, 2, and 3 all have 0 for read. We can't read them. And so that's what happened here in the cat loop. 0 denied, 1 denied, 2 denied, 3 denied. We can't read them. And then we spit out the contents of the file for the other, for the remaining 4, because the last 4 I can read, so I can cat. What is next? And the next is that I am appending to the file. So there, let me erase that. So now I'm down here in the 26 loop, and that is here where I am appending. And I don't see anything when it works. I only see something when it doesn't work. And so I'm appending, I'm writing, and and it is 0, 1, 4, and 5. That's when I can't write. So 0, 1, 0, 1, 4, and 5. That's when I can't write. So that is consistent. So that's what that means. I can't, I'm trying to write and I don't have permission to write on the 0, 1, the 4, and the 5. The execute, I had the execute with the bash command, and we see it was denied, 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 4 denieds, and then 4 accepted again, because when we run with the bash command, what we care about is, can it be read? It doesn't need to be executable because that's going to be handled by the bash command, but it does need to be read because the code needs to be read so it can be interpreted and then execute. And so it needs to be interpreted before it can be executed. So we don't care about whether it's executable or not. We care about whether it's readable or not. And the same as before, the first 4 cannot be read. So it was denied, 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 deny, and then it worked. And we get the printout of the hello world when we run the program. The last loop is running the command using // So we're going to rely on it being executable and readable. If we can't read it, it won't run. And if we can't execute it, it won't run. And so this is mostly deny, deny, deny. 0 denied, 1 denied, 2 denied, 3 denied, 4 denied, 5 worked, 6 denied, 7. So 5 and 7. And 5 and 7 were the ones that were read and execute, read and execute. Okay, so that was my funny little program to explore the various permissions. All right. Thank you for your attention.